my examination in the examination point of view, you have to learn properties of good estimator. It has been following characters: consistency, unbiasedness, efficiency, and sufficiency. These four topics they will ask in the maybe ask in the main examination as a sub 4 question marks here. So what is the consistency? What is the consistency of the meaning here? The term consistency is estimator, the short term for consistency of sequence of estimate. What is the meaning of sequence? The numbers I already told in the practical sessions also. Estimator of short for consistent sequence estimators. The idea of the consistency is the repeat of the estimator results again and again. I am telling that the repeat of the estimator results again and again with a steadily increasing sample size. So we are why? Because we are taking the results, but the samples increasing sizes eventually, assuming that the estimator is constant, so the sequence will coverage in the population of the parameter. So the convergence is called as the limit. Until when we are taking as a limit and the basic of the consistency here, we can take in the assuming these estimators. So the coverage of the true population we can call as that one limit. So what is the consistency? So theta n. So theta n will be good estimator in the difference of what is the difference between the modulus of theta n minus theta is a small possible, but theta n is a random variable and it has its own sampling distribution. Why? Because the modulus of theta n minus theta is a small possible, but theta n is a random variable and its own sampling distribution. Why? Because theta 1, theta 2, theta 3 is a normal variables, but theta n is until the number is a random variable and it is the own sampling distribution whose range may be finitely large. The sampling distribution of theta n becomes a more concentrate around the parameter, the sample size increases. Theta n, the sample distribution theta n becomes more and more concentrated around the parameter of size increases. So in that means that the theta into p, so modulus of theta n minus theta less than epsilon. అంటే మనం theta n minus theta epsilon cap less than epsilon అయినప్పుడే అది కన్సిస్టెన్స్ గా ఉంటుంది. ఫర్ గివెన్ ఎప్సిలాన్ గ్రేటర్ దెన్ 0 should be an increasing function n. The idea of leads the concept of consistency as a criterion of a good estimator. Moreover, the consistency of this idea sequence of the estimator rather than one point estimator. Rather than one point estimate, we are assuming here. So definition of the consistency. A sequence estimated theta n is said to be consistent if and only theta n to theta. So denotes the convergence in probability here. So you have to write all these consistency definition for the good estimator first one. So if any words missing, you have to write the theta cap of theta n cap of to theta p, where p denotes convergence is probability. So theta n is said to be consistent limit instance to infinity. P theta minus theta less than epsilon. So theta minus theta less than epsilon greater than 1 minus n for every neta greater than 0. These conditions you have to write. Then consistency is the basic conditions you have to follow. Any doubts, ask me. Mark, pass. Any doubts for consistency? Sumaya?
No, sir.
Okay. Yes. Example, we have to see one example. Let a sample has been drawn from a normal population. Let a sample has been drawn from a normal population with a mean mu and variance sigma square. Let sample an xn cap summation of xi by n is a constant of estimator of parameter mu. So see here, little theta cap summation of xi by n is an estimator of mu. So xi cap is an independent variable, independent and identical distributed random variable. So E of xi is equal to mu and V of xi is equal to some sigma square of all xi. But the basic condition is summation of xi by n. So we can take that as Vxi sigma square for all I. Then Bn, V is equal to x1 plus x2 plus xn and so on. In Vxi covariance will be xi's of IIDs. What is the meaning of IIDs? So beta n is equal to n square and sigma square. Hence, limit n stands to infinity beta n by n square. So sigma square by n is equal to 0. IIDs, we can get that x1 plus x2 plus xn by n minus mu less than epsilon 1 minus neta. So for every n greater than n naught implies that p x bar n minus mu less than epsilon by n stands to infinity, then show that x bar n convergence is the probability. Mu as n stands to infinity. So xn is equal to summation of xn, but is a constant of estimator of parameter. No, this is the basic condition here. What is a weak law? What's the weak law of large numbers we have taken here? What's the weak law of large numbers? Let x1 and x2 and x3 and x4 and so on. Xn be a sequence random variables mu1, mu2, mu3 and so on. Mun with the expectation of the variables of the respectively. An is equal, we can write that v into x1 plus x2 plus x3 plus and so on xn. So basically conditions of the both the values are minus in subtraction method p into x1 plus x2 plus and so on xn by n minus mu1 plus mu2 plus and so on mu n by n. So both are less than epsilon we are doing here. So 1 minus eta for all n greater than n naught. So where epsilon and eta are some arbitrary small positive. So these conditions, right, we can weak large of numbers. What is unbiasedness? This is the one-sided unbiasedness. That x is equal to x1, x2, xn is a based on the distribution having a parameter value theta, and theta cap n is equal to theta cap n x1, x2, xn, and an estimator of theta. Then the bias is defined as b theta is equal to e theta n x1, x2, xn, and so on xn minus theta. B theta is equal to 0 for all values of the parameter theta n x1, x2, xn is called as, so theta 1, theta x1, x2, xn. So theta cap and x1, x2, so x3, xn is called as unbiased estimator. Any estimator that is not unbiased is called biased estimator. So, E cap n x1, x2, xn minus theta is called as biased estimator. Why? Because it should be equal to 0 of the values of the parameter. So called is unbiased estimator, but greater than 0, the condition of the unbiasedness less than 0, greater than 0, b theta greater than 0, then theta cap then x1, x2, xn is said to be positively biased estimator. B theta greater less than 0, theta n x1, x2, xn is said to be negatively biased estimator. One example we have to see here. One example, see here. So xi, n sigma square, x bar is equal to x1, x2, xn by n. So unbiased estimator in the practical class, I told that Komal also here joined. N equal n mu sigma square. E of x is equal to mu, v of x is equal to sigma square. So E into x1 plus x2 plus and so on xn by n. So we can write by that is a condition n mu by n. So n get cancelled, that is equal to mu. The basic some examples you have to see all the examples in the explanation of in the class. Any doubts, ask me, I will clarify. So this is the remarks. So what is the efficiency? So what is the efficiency means? So what is the definition of efficiency? Let a random. What is the meaning of random variable? What is the meaning of random variable? Random variable. Please respond. What is random variable? Is there anyone class? Okay, let a random variable x follows a normal distribution with the mean mu and variance sigma square, but x equivalent to n mu sigma square, we know that sample mean x bar by summation of xi bar is a constant and unbiased estimator, but of the population is mean, we are taking mean is mu. In general, the diagnostics is more than one consistent estimator population parameters such as population of mean mu. It can be shown the example of median m. So mean is mu, median is m as unbiased and consistent estimate of the population mu. From this, it can be understood there should be a criterion choose one among them. A criterion which it is based on the variance of the sampling distribution of unbiased estimator is known as called as efficiency. But mu is the criterion which is based on the variance of sampling distribution. If there are k consistent estimators, I is equal to 1 to k of population of parameter, then an estimated theta I is said to be estimated v theta I less than v theta j. Already theta I and theta j. So both are the population of. Just a minute. So population mu, from this it can be understood that should be a criterion to choose among them, a criterion which is based on the variance of the sampling distribution of unbiased estimator known as efficiency. We are uh, taking here, we are doing here. So definition: if there are a consistent estimators, theta I is equal to 1 to k population of parameter, then theta I, v theta I theta j for all j not equal to I, j not equal to I untene అది అవుతుంది కాబట్టి j not equal to I we are taking here. So the efficiency E is defined as the most estimator to the variance of any other estimator. So variance of X is sigma square by N. So variance of M, the condition is 1.57 sigma square by N. The large condition we are taking Vx bar less than Vm. So hence it is concluded the sample mean X bar is an efficient and estimator of population mean that the sample median. The efficiency of the estimated sample mean over the sample median is computed as sigma square by n 1 point sigma square. There is a value is 0.6.39. So you have to this one, and another example we have to see here. Well, okay. Random sample x1, x2, xb is the size of 8 drawn. Normal population with the mu sigma square. So theta 1 cap is equal to x1 plus x2 plus x8. So theta 2. This is the basic fundamental formula. Komal and Komali both are listening. Yes, please respond.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
No, okay. So this is the fundamental formula. This is the fundamental formula. So theta 2 kya but formula name 8 by 87 1 by 4 x plus x5 4x2 plus 687 3 by 8 q theta 3 and this formula name. You should, this is the formula should be learn, but the theta 1 cap is unbiased estimator for mu. Theta is theta 3. Find the most elements. So we are finding these values, say x1 plus x2 plus x8 by 8 and 1 by 8 common this term. Summation of I is equal to 1 to 8 xi. So 1 by 8 summation of I is equal to 1 time 1 by 8. So 1 by 8 ఏమని రాస్తాం దీన్ని సమ్మేషన్ ఆఫ్ 1 by 8 xi ని 8 mu అని తీసుకుంటున్నది ఈ మొత్తాన్ని 8 mu 8 get cancel. What is the value here? What's the value here? Mu. So what is the value here? What is the value here? Is there 3 here? So therefore theta is unbiased estimator of mu. E theta 8 by 87, the formula they have given. 8 by 87 x1 plus x5 4 x2 6 x3 3 by 8 x power 4. So this is 8 by 27. I am taking the multiplication of the by division. So 27 taken in the by division 1 by e5 x4 plus x5 4 x2 6 e power x7 3 by 8. The 87 now 27. This is the 87. You have to capsule this is now 27 8 by 87. This is also same 1 by 4 2 mu 4 mu. So theta is unbiased estimator. You have to b is calculate the same the procedure for the same value here. Any doubts, ask me, I will clarify. Make fast. ఒకసారి ప్రాక్టీస్ చేయండి, పెద్ద ఇంపార్టెంట్ కాదు. ఓకే
ఓకే సార్.
అవసరం లేదు, అవసరం లేని స్కిప్ చేసేస్తున్నాను. ఇవైతే మోస్ట్ ఇంపార్టెంట్ అండి. Unbiased estimator, consistent estimator, efficient estimator. Any doubts in this one, ask both. కనపడుతుందా మీకు? కనపడుతుందా? ఓకే
సార్
కనపడింది కదా రౌండ్?
కనపడింది సార్.
రైట్. In the second one, MVUU lo, so complete sufficient statistics, minimum variance, unbiased estimator we have to take here. So what is the sufficient? So what is the sufficiency? Let x comma theta is a family of density function. Theta is unknown. Theta is unknown. Parameter, a random sample of size n taken from f of x comma theta. make statistical inference about the parameter theta. T is a statistics function of the random sample which can exhaust all the information contained in the random sample about the parameter theta. Is a sufficient statistic here. Here also, estimator T is said to be sufficient. Estimator is said T is said to be sufficient parameter to all the information of the sample pertaining to the population parameter. T is equal to theta x1, x2, x2n is the estimate of the parameter based on the sample. X1, x2n is the size n from a population with the probability density function. So the conditional distribution of any other statistics. T dash, which is independent of T. T is independent parameter of theta. So T is said to be sufficient of estimated theta. Most important one, this one, the small question, mathematical definition of sufficiency. They will ask in the examination. Suppose that x1, x2, x3, x4, and so on, xn, that is equivalent to f of x theta. T is sufficient for theta conditional distribution. What is the meaning of conditional distribution? Anyone tell me? Conditional distribution, Komal. Komala, are you listening? Okay. Distribution x1, x2 is suppose the conditional distribution అంటే ఆ కండిషన్ మాత్రమే మనం అప్లై చేయబోతున్నాం. x1, x2 d does not depend upon the theta. So phi is equal to x1, x2, xn by t. Phi is equal to x2, x1, x2, xn, that is t. Just a minute. Just a minute, Amma, wait చేయండి. Komali.
Okay, sir. Okay, sir.
Oh, 2 minutes. సో x1, xn ఇద్దరే ఉన్నారు క్లాసులో, ఏందో మరి. ఓకే,
అంతే సార్ అది.
మీ మిత్రురాలేది?
మా మిత్రురాలకి నెట్ సరిగ్గా లేదండి సార్.
ఓకే,
సరే సార్.
ఇగో ఓకే. Komal and Komali are listening. What I am.
Okay, sir.
What?
Okay, sir.
Okay. See here, this is a Fisher-Neyman factorization theorem. Most important theorem. Should understand. Any doubts, ask me. Let of be a random sample size of n. Random sample అంటే ఏంటమ్మా? Random sample అంటే మనం random గా పికప్ చేస్తాం. It is a raw. It is a not as a random sample from is f of x, comma theta, whose range is independent of theta. Theta is independent, but x1, comma x2, comma xn, the necessary and sufficient condition of f of x, comma theta అంటే ఆ sufficient condition కి admits the sufficient statistics. అంటే f of x, comma theta కి ఆ కండిషన్ కనుక సాటిస్ఫాక్షన్ అయితే the probability distribution of function, the phi of 1, x1, x2, xn splits over the product of two negative non-negative functions v theta comma t. Wx is equal wx1, x2, and so on is independent of theta. So wx is equal to wx1, x2, and so on xn is independent of theta. Then t is called of sufficient statistics for theta. T is sufficient statistics for theta if and only phi of x1, x2, and so on phi of I is equal to 1 to n f of x1 theta, vi is equal to t f x1 x2 and so on xn into w x1 x2 xn. అంటే ఆ కండిషన్ ని కనుక మనం సాటిస్ఫై చేయగలిగితే ఫిషర్ నియమంలో, ఫిషర్ నియమం ఫ్యాక్టరైజేషన్ దీనిలో టీటా అనేది ఇండిపెండెంట్ అయి ఉండాలి, ప్రాబిలిటీ డెన్సిటీ ఫంక్షన్ phi of x1 x2 xn అయి ఉండాలి, అది నాన్ నెగటివ్ ఫంక్షన్ అయి ఉండాలి, v is equal to theta, w is equal to w x1 x2 xn అయినప్పుడు టీటా అనేది సఫిషియెంట్ స్టాటిస్టిక్స్ అయితే, t is sufficient statistics when phi is equal to x1 x2 xn is equal to phi of I is equal to 1 f of x1 theta, va is equal to t x1 x2 and so on xn into w is equal to x1 x2 xn. This is the only statement I am telling. This is statement. You have to write the statement they will ask in the examination. Where v theta t of x and w x are non-negative functions, the function wx depends upon the complete random x1 x2 xn, but not on the unknown parameter theta. The function v theta of x depends on theta, but can depend on the random sample only through the value of t x1 x. This is the total entire statement of Fisher-Neyman factorization theorem. See here, what is the sufficient condition? So it is given that phi is equal to x1 x2 so on xn, v theta is equal to theta x1 x2 x3 x4 and so on xn into multiplying w into x1 x2 xn. What is w into xn xn? See here, I am already told w into wx is equal to w is equal to x1 x2 xn is independent of theta, but the pdf of f is equal to phi is equal to x1 x2 xn. So I am these two values I am multiplying here, w t into x1 x2 xn into w into x2 x1 x2 x3 xn, where w is independent of theta. Rewrite the above equation. Rewriting the above equation, we are here phi is equal to x1 x2 x3 xn ve t into x1 x2 xn into u into x1 x2 xn. t తీసుకున్నాం, u తీసుకున్నాం, రెండింటిని మల్టిప్లై చేస్తున్నాం, then multiplying phi of x1 x2 xn. Already I told you this is a conditional distribution. So phi is equal to x1 x2 and so on xn by t, which is equal to w x1 x2 so on xn. P into t dash by t is independent of theta. So p is independent of theta we are taking here. P into t dash by t, first we are taking the differentiation. T is sufficient estimate theta. So necessary and condition is given that sufficient estimator of theta. So let t, what is the t condition? Y2, y, no, there is no y1 is there. Y2, y3, y4 transformation of random variables x1, x2 and so on xn respectively. So let g, t, y2, y3, yn is the joint of PD of x1, x2, xn. G, t, y2, y3, yn and phi x1, x2 are joint PDF of x1, x2 and so on xn. Then we know that t తీసుకున్న ఫస్ట్ కండిషన్ తీసుకున్నప్పుడు y ఉండదు. సో y2, y3, yn is equal to phi of x1, x2, xn ఉంటుంది. t కండిషన్ తీసుకుంటే y1 కండిషన్ ఉండదు కాబట్టి that is 1 by modulus of j. So hence the Jacobian, the transformation. What is the Jacobian? What is the Jacobian transformation of j? Dou by new variables, dou by new variables. So what is the new variables and what is the old variable? So dou by new variables, what is the old variable? So see here, dou t by dou x1, dou t by dou x2, dou t by dou x3 and so on, dou t by dou xn. Dou y2 by dou y1, dou y2 by dou x2 and so on, dou y2 by dou xn. So dou yn by dou x1, dou y2 by dou x2, dou yn by xn. అంటే ఫస్ట్ t తీసుకున్నాం, తర్వాత y2 తీసుకున్నాం, తర్వాత సో ఆన్ yn తీసుకున్నాం. డినామినేటర్ లో x1 x2 xn అనే ఫంక్షన్స్ మారటం లేదు, మారవు, ఎందుకంటే పైన న్యూ వేరియబుల్స్ కింద ఓల్డ్ వేరియబుల్స్ తీసుకుంటున్నాం కాబట్టి. The marginal density function of sufficient statistic t is given by v t comma theta, v theta t x1 x2 and so on xn integration of g. అంటే ఇంతకుముందు చెప్పిన t తీసుకున్నప్పుడు y1 అనే కండిషన్ ఉండదని y2 y3 so on yn d1 dy1 dy2 and so on dy1 dyn. We know the conditional density of y2 y3 and so on yn. So y1 is not there, y2 y3 y4 and y5 and so on up to the condition y1. So y2 y3 yn by t, it is equivalent to g into y2 y3 and so on yn. అంటే y2 y3 ని l లో y2 y3 తీసుకుంటే g లో b of theta తెలుసుకుంటాం, g is equal to t y2 y3 and so on yn b theta comma t into l, that is y3 into y3 and so on yn by t గా మనం ట్రీట్ చేస్తాం. Since it is a sufficient estimator of theta, the conditional density we are taking y2 y3 y4 and so on yn by t is independent of theta. When is independent theta? G is T y2 y3 yn is equal theta into L y2 y5 2.2 is independent of the estimator theta. Hence it is a function x1. Now the equation 2 becomes z theta t y2 y3 yn into v theta. So we are multiplying y2 y3 yn by theta, equating 1 and 3 we have here. We are taking here x2 x1 x2 xn are already x1 x2 xn x. We are told here we into theta into w dash y2 y3 yn modulus of j v comma theta into w y2 y3 yn w dash y2 y3 and so on yn modulus of j w y2 y3 jan. It is a j Jacobian is independent of theta. So independent of theta it is called as sufficient of statistic. With the probability density function, it splits into two density functions. So this is called as Fisher-Neyman factorization theorem. Any doubts? Any doubts in this theorem?
No, sir. No, sir.
Okay, write it once again. Any doubts, ask me.
Okay, sir.
But the new variables or old variables you have to write. Example. Let x1, x2 and so on xn be a random sample drawn from a Poisson population with a parameter lambda. Find sufficient estimation for data. Given that x equivalents to p lambda with the joint probability density function phi is equal to x1, x2 and so on xn, phi is equal to 1 to n e of minus lambda lambda x by x by. So this is the one we are taking here, e of minus lambda e power minus lambda lambda x power 1 e power minus lambda lambda x power 2 e power minus lambda x power 3 by x1 factorial x2 factorial x3 factorial. There is a different factorials up to we are taking e power minus lambda lambda power x power n by x power n factor e power n factorial e power n lambda lambda into e power xi phi I is equal to 1 to n xi lambda e power minus n lambda exi into 1 by summation of I is equal to 1 to n xi t1 v into summation of xi lambda wx. So summation of xi is a sufficient estimator of lambda is Poisson distribution. అంటే ఇక్కడ మనం వాల్యూస్ ఏం చేస్తున్నాం, ఇక్కడ వాల్యూస్ అన్నిటిని తీసుకుంటే సింప్లిఫికేషన్ చేస్తే e minus n lambda by some lambda sum xy lambda is equal to 1 summation of xi e n minus lambda బయటికి తీసుకొస్తాం డిఫరెన్షియేషన్ లో. సో 1 by 5 lambda was equal to xi. This is called a sufficient estimator of Poisson distribution we are taking here. Another example we have to see here. Adigamma, Komali.
ఫిషర్మన్ థీరం అవుతారు సార్. ఫిషర్
అర్థం కాలే
ఇదంతా ఇస్తారా?
అమ్మా
క్వశ్చన్ సార్.
ఫిషర్మన్ ఇప్పుడు they will ask state and proof Fisher-Neyman factorization theorem అంటే ఇక 2.2.2 మొత్తం రాయాలి ఇదంతా ఇక్కడ వరకు.
ప్రూఫ్ దగ్గర నుంచి రాస్తే సరిపోతుందా?
లేదు, స్టేట్మెంట్ కూడా రాయాలి. వాడు స్టేట్మెంట్ ఇస్తే అవసరం లేదు, స్టేట్మెంట్ ఇవ్వకపోతే స్టేట్మెంట్ కూడా రాయాలి.
స్టేట్మెంట్ కూడా రాయాలా?
ఈ స్టేట్మెంట్ రాయాలి, ఈ స్టేట్మెంట్ అంతా రాయాలి.
ఓకే సార్.
స్టేట్మెంట్ అంతా రాసి అంటే సపోజ్ forgotten the statement, you have to write phi is equal to x1 x2 xn, phi is equal to y is equal to 1 to n f x and y, therefore vi is equal to t into x1 x2 so on w into x1 xn. There is a random sample అన్న రాయాల్సి వస్తుంది.
ఓకే సార్.
ఓకే
సార్.
Then one other example we are taking here. Let x1 x2 and so on xn be a random sample drawn from a normal distribution with mean mu and variance sigma square. Find sufficient estimator for mu and sigma square. Solution: given that x equivalent to n mu sigma square, that is theta is equal to mu comma sigma square parameters to be estimated. How it is estimated we are thinking here. The joint PDF is given by phi x1 x2 xn phi of y f of theta xy. That is we are writing already in the class I told 1 by sigma root I e into minus 1 by 2 sigma square x1 minus mu square, same x2 minus mu square, that is xn minus mu square. We can write it or not?
Yes sir.
అప్పుడు ఏం చేయొచ్చు, దీని సింప్లిఫికేషన్ లో 1 by sigma root I n e 1 by 2 sigma square sum I xi minus mu square 1 by sigma root pi whole power n e power 1 by 2 a square summation of I xi square minus 2 summation of xi. Let's say a minus b whole square formula వాడామా లేదా? So that's the condition may be satisfied. Summation of xi minus lambda I summation of xi square. This is also summation of x and summation of x square sufficient statistic mu and sigma square is respectively. Most important, complete sufficient statistics. What is complete sufficient statistics? A sufficient statistics whose sampling distribution is complete, we say that it is complete sufficient statistic, complete the family of densities. A family density f of xi minus theta is said to be complete if the function of random variable x whose expectation is 0 for all theta belongs to what is the symbol? What is the symbol?
మీరే చెప్పండి.
ఓం.
ఓమా?
ఫిజిక్స్ లో వస్తుంది.
మేము ఫిజిక్స్ కాదు కదా సార్.
is identical equal to 0. In other words, f of xi theta is said to be the wx is equal to 0. We say that f of xi theta is called complete family density is wx is function of s. Show that short question. Maybe ask in the short questions. Show that binomial family density of complete. Consider the binomial density function p of r, n of r, phi of r, 1 minus pi n minus r. Let WR is a function, then from the distribution EWR is equal to 0. WR, NR, pi of r. So see here all of you. EWR is equal to 0. This is NCR. Is NCR avuna? NR and NCR ena? Summation of r is equal to 0 to n WR NCR pi of r 1 minus pi n minus r. So 1 minus pi n I am taking the common here. Summation of I is equal to 0 WR NR. So we are taking the r here. We are taking the simplification of WR NCR. So r అనేది కనుక తీసుకుంటే ఇక్కడ pi by 1 minus pi whole power. This is the simplification of this one. This by pi by 1 minus pi whole power r is equal to 0. You have to do simplification. Summation of r is equal to gen BR NCR x power r is equal to 0. Also we are taking here. So when B of r NCR WR is equal to meter asham pi of by 1 minus pi. 1 minus pi whole power n is not equal to 0 or equal to 0?
Not equal to 0 sir.
Not equal to 0. ఎందుకు? అది nth condition కాబట్టి. So BR, NR, NCR, WR is equal to 0. So NCR అనేది not equal to 0 అవుతుంది కాబట్టి binomial of densities are complete. Why? Because not equal to 0, 1 minus 5 whole power n అనేది not equal to 0 అవుతుంది కాబట్టి E of WR is equal to 0. So binomial of densities are complete in here. Show that the exponential family of density is complete. This is also an important question here. Let f of x comma theta into e power minus theta x theta 0 less than x less than delta, and let wx is function of x. So e of wx is equal to 0, integration of 0 to infinity wx theta into e for e minus e power x theta x is equal to 0, integration of theta to infinity wx integration of e into minus theta power d is equal to 0. So both the theta equal to 0 or theta not equal to 0?
Theta not equal to 0.
Theta not equal to 0. So theta not equal to 0. Let theta by wx. Theta not equal to 0. Theta by wx is equal to 0. So that the Laplace transformation, a function whose Laplace transformation value is 0 itself. So wx is equal to the exponential family of density is complete. The two questions compulsory short questions అడిగే అవకాశం ఉంది కాబట్టి చదువుకోండి. Minimum variance of unbiased estimator MVUU. Already I told in the classroom. In class of consist estimator of there two exist more than unbiased estimator of parameter. The interest of finding the most efficient estimator of parameter. There are several ways to find the efficient. Rao-Kramers inequality, Rao-Bloch Williston. What is the Rao-Kramers inequality? So with the statistics T, x1, x2, so on, xn is based on the sample size. T is unbiased. It has the least variance. and the class of all unbiased estimators of theta ante unbiased ayyuntene MVUU condition చూడొచ్చు. So the statistics T is called minimum variance of unbiased of estimator of theta. So MVU estimator of unique sense T0 and T1 of MVU estimator of theta. T0 is equal to T1 almost everywhere we are taking here. So theorem. So there is a MVU estimator T0 T1 and MVU estimator of theta is there. Since both T0 T1 of unbiased estimators, T0 is equal to ET1, theta V is equal to theta for every theta. అంటే E of T is equal to 0 అని మనం E of T is equal to 1 అంటున్నాం. కానీ అది theta అయినప్పుడు అది for every theta అవుతుంది. కానీ both the minimum variances. What is the minimum variance here? V theta is equal to V theta 1. మనకు తెలుసు. Let us consider linear combination T0 T1 is equal to T is equal to T01 plus 1 T by 2. The E of T is equal to theta. So variance of T is equal to T0 plus T1 by 2. Here we have written the basic fundamental formula 1 by 0 VT0 VT1, 2 covariance of T0 T1. So 1 by 4 so we are taking here VT0 VT0 VT1 square. So covariance in simplify is a 2 sigma under root of VT0 T1 under root. This is the simplification of covariance. So 1 by 4 VT0 VT1. This is a simplification of 2 V this one 2 sigma VT0 VT1 called as VT0. చూద్దాం మీది పోయి VT0 ఇచ్చినాడా. VT0 is equal to VT1, VT0 is equal to VT1 కాబట్టి so VT0 1 by 2 into VT0 2 VT1 2 sigma 1. So 1 plus sigma we are taking the common. There's a 2 to get 2 common is a 2 to get cancel here. 1 by 2 VT0 VT1 this is a simplification of the from expression of the 2.5 we are taking here. So 1 plus sigma we are taking here. So there is a correlation coefficient between T0 T1. So MV estimated defined by VT0 less than VT greater than V0. This is a condition less than greater than some half of VT0 1 plus rho greater than P0. So therefore 1 by 2 1 plus rho greater than 1. So P greater than or equal to 1 ga. You can write these estimations in this one. But rho cannot be more than UDT. So for each theta, T0 and T1 must be linear rated almost everywhere. Theta, A theta and B theta, more constants in x1, x2, xn may depend upon the, it can be derivated here. E T0 is equal to A theta plus B theta, ET1. A is equal to A theta plus B theta into theta we are taking here. So అంటే A theta ni B theta ni ET1 గా రాసుకుంటే A theta 1 B theta 1 గా రాసుకుంటే theta is equal to A theta into B theta and beta. So theta is equal to A theta into B theta. 2 points from 2.7 అన్నాడు చూద్దాం 2.7 లో ఏం రాశాడో theta into A theta plus B into theta 1. So 2 into A theta plus B theta 1 ప్రకారంగా V0 is equal that is a condition B square అవుతుంది. దీన్ని సింప్లిఫై చేస్తే B square of theta theta 1 B square theta is equal to 1 2.5 లో V T0 is equal to T1 కాబట్టి V T0 T1 is equal to B square is equal to theta from 2.5. B square theta is equal to plus or minus B square theta is equal to plus 1 and rho is equal to plus 1. So therefore B square is equal to B theta is equal and B square is equal to 1 of B theta is equal to plus or minus 1 అవుతుంది. So the expression under the equation from the 2.8 A theta plus theta is equal to theta అంటే ప్లస్ లో తీసుకున్న మైనస్ లో తీసుకున్న the value is 0. So theta 0 is equal to theta naught theta 0 is equal to theta 1 almost everywhere. So the condition is satisfied here. So అంటే ఇక్కడ ఏం చెప్తున్నాం మనము theta 0 ను theta 1 ను less than greater than condition లో రాసుకొని దాని కోరిలేషన్ కోఎఫిషియంట్ MVU ఎస్టిమేటర్ సాటిస్ఫై అవుతే ఈ కండిషన్ సాటిస్ఫై అని చూపిస్తున్నాం. క్లియర్
Yes, sir.
Suppose T0, T1 and 2 unbiased estimated theta with variance of VT0 and VT1 and correlation between the 2 unbiased estimated sigma. What is the best unbiased linear combination T0 and T1 and what is the variance of the derived component? See here, for the derived component here we are taking here. What's the derived component here? Given that T0 and T1 are two unbiased estimator, అన్బయాస్డ్ ఎస్టిమేట్ అంటే ఈ టీ నాట్ ఈజ్ ఈక్వల్ టు ఈ టీ వన్ రాయొచ్చునా? రాయొచ్చునా రాయరాదా?
రైట్ సార్.
ఈజ్ ఈక్వల్ theta. లెట్ బి లీనియర్ కాంబినేషన్ T0 T1 ఏమని రాయొచ్చు? T ఈజ్ ఈక్వల్ L0 T0 L0 T1 అంటే T0 T1 L0 T0 L0 T1 గా రాస్తే where L0 and L1 arbitrary constant do not depend upon the random sample x1, x2, so on xn, but maybe depend on theta, then we have e power t is equal to L naught e t naught L1 E1 T1. చూడండి, L naught E naught T naught అంటే ET. ఇక్కడ ఏం చేసినాం? ఇగో L naught బయటికి తీసుకో, L naught ఇక్కడ రాసినాం, అవునా? L1 ఇక్కడ రాసినాం. ఏం మిగిలింది మనకు? టీటా మిగిలింది. ఇలాంటి అంటే ఏం రాయాలి? ఈ ఆఫ్ టీ నాట్ ఈ ఆఫ్ టీ వన్ ఏమని రాసినాం? ఈ ఆఫ్ టీ అని రాసినాం. సో ఎల్ అంటే ఈ కండిషన్ ఈ ఆఫ్ టీని ఎక్కడ కొడితే ఏమవుతుంది? ఎల్ నాట్ ప్లస్ ఎల్ వన్ ఇంటూ టీటా. క్లియర్?
సార్.
So T is unbiased estimator of theta if and only L naught plus L1 is equal to 1. E of theta is equal to theta. From 2.9 we have VL Vt is equal to L naught square plus V naught L1 Vt1 L0 L1 కోవారియన్స్ ఆఫ్ T0 T1. ఇంతకు ముందు చెప్పిన ప్రాబ్లం లో ఒకసారి మీది పోతున్నా నేను కోవారియన్స్ కి. ఇక్కడ చెప్పామా? 2 ఆఫ్ కోవారియన్స్ టు T0 T1. 2 what is this symbol? What is this symbol? What is this symbol?
రో.
అమ్మాయ నా జన్మ ధన్యమైందా?
ఎందుకో
మాట్లాడినారు కదా. సో రో. సో 2 LO L1 కోవారియన్స్ ఆఫ్ T0 T1. సో ఆ ప్రకారంగా రాశాను. VT L0 స్క్వేర్ VT నాట్ L1 V T1 2 L0 L1 రో. సో కోవారియన్స్ లో రూట్ రాస్తున్నాం. అండర్ రూట్ ఆఫ్ VT నాట్ ఇంటూ VT1. T will be the best unbiased V of T. So let us minimize L0 plus L1. Consider the likelihood function in we are taking here. So L is equal to L0 square VT naught, L1 square VT1, 2 L0 L0. మీద రాసాము మన ఫార్ములా. Under root of VT naught into VT1. This is into naught x plus lambda L1 minus L0. Differentiate చేయండి. Dou L by dou L0. ఎవరు చెప్తారు? డో ఎల్ బై డో ఎల్ నాట్ కరెక్టా కాదు? ఒకసారి చెప్తారా నాకు? కోమలి ఒకసారి చెప్పమ్మా. డో ఎల్ బై డో ఎల్ నాట్ ఈజ్ ఈక్వల్ టు 0. ఇగో ఎల్ నాట్ స్క్వేర్ అంటే 2L0 రాసుకోవచ్చమ్మా?
రాసుకోవచ్చు సార్.
VT నాట్ అది కాన్స్టెంట్, ఇట్స్ బెట్ అక్కడ. L1 స్క్వేర్ అంటే 2L1 రాసుకోవచ్చు. 2L1 VT1
జీరో సార్.
అయ్యా
సెకండ్ టర్మ్ జీరో.
ఏ సెకండ్ టర్మ్?
ఇదే L1 స్క్వేర్ V ఆఫ్ T1 ఉంది. అక్కడ L0 టర్మే లేదు, మొత్తం జీరోగా.
అర్థం కాలే నాకు. కోమల్ L0 స్క్వేర్ 2L0 V0 ఇస్ కరెక్టా? ఇక్కడ ఏంది? 2L1 V. విను నేను ఇంకా క్లియర్ చేయలేదు, చెప్పబోతున్నా నీకు నేను. ఎందుకు జీరో?
L0 టర్మ్ లేదు కదా.
L0 టర్మ్ లేదు ఇందులో కాబట్టి. కానీ వెరీ గుడ్, L0 టర్మ్ లేదు ఇందులో. కానీ ఇక్కడ L0 టర్మ్ ఉంది కాబట్టి ఇది 2L0. L0 ఇంటూ L0 అంటే పార్షియల్ డిఫరెన్షియేషన్ లో L0 ఇంటూ L0 ఉంటేనే వాల్యూ రాసుకుంటాం, అవునా? అంతేనా కోమల్?
అంతే సార్.
వెరీ గుడ్ బాగానే వింటున్నారు. ఓకే, this L0 into L0 1 2L1 under root of VT0 into VT1 minus this is also L0 అంటే 1 minus 1 ఏ ఉంటుంది ఇక్కడ. 1 minus L1 లేదు కాబట్టి ఇది 0 కాబట్టి 1 into minus lambda. క్లియరా? ఓకే. డో ఎల్ బై డో 1 చూడండి అమ్మ ఒకసారి. డో ఎల్ బై డో 1 కరెక్టా రాంగా?
కరెక్టే సార్.
కరెక్టే సార్.
ఇది 0 అవునా?
ఎస్ సార్.
2L1 VT1 2L1 ఓపు సేమ్ యాజ్ ఇట్. సో డో L బై డో లాంబ్డా ఉందా ఎక్కడన్నా? ఇక్కడ ఒక్కటే దగ్గర ఉంది అవునా? ఇది 0నే,
Yes,
ఇది
sir.
0నే, ఇది 0నే. సో టోటల్ వాల్యూ 1 into లాంబ్డా లాంబ్డానే కాబట్టి మల్టిప్లై చేస్తే 0 అవుతుంది. సో L0 plus E1 L0 plus L1 is equal to 1. So 2.12 and 2.13 both the values I'm taking here. 2L0 VT T0 plus 2L1 rho under root of VT0 into plus VT1 minus lambda. 2L1 into T1 రెండింటిని మనం కంపేర్ చేస్తున్నాం. 2.12 and 2.13 ని కంపేర్ చేస్తున్నాం. సో L0V T0 L1P ఏం కామన్ తీసాం సార్ ఇందులో? 2 కామన్ తీసాం. 2 2 2 2 అవునా? అవునా కాదా? 2 తీసేసాం. మరి చెప్పున్నమ్మా. సో L1P, so this is a simplification of the above equation.
హలో సార్.
వినండి, L0V T0 మైనస్ L0V T0. ఇగో ఇది L0 అంతా ఒకసారి తీసుకొస్తున్నా. ఈ L0 ఫంక్షన్ అంతా ఇటు తీసుకొస్తున్నా. సో L0P అండర్ రూట్ ఆఫ్ VT01. సో L1 T1 ఇగో ఈ L1 అంతా అటు పట్టుకపోతున్నా. L0 ఒక సైడ్ కు L1 ఒక సైడ్ పట్టుకపోవచ్చా లేదా?
సార్
తీసుకెళ్ళచ్చు. ఓకే, తీసుకెళ్ళాను. తీసుకెళ్తే L0 ఇందులో నేను ఏం చేశాను? L0 కామన్ తీశాను. VT0 రో ఆఫ్ V ఇంటూ T0 ఇంటూ VT1. ఇక్కడ ఏం కామన్ తీయవచ్చు చెప్పండి నాకు?
L1 V.
కోమల్
ఇదేనా మీ సార్ది?
L1 సార్. ఇది 1
ఏం రాయాలి ఇక్కడ? L1V 1 మైనస్ L0 కోమల్?
ఇక్కడ L1 ఒక్కటే సార్. L1 ఒక్కటే కదా.
ఇప్పుడు ఇది కామన్ ఏం రాయాలి అని అడుగుతున్నాను నేను నిన్ను.
L1
ఓన్లీ L1 రాయాలి. దిస్ ఈస్ ఓన్లీ L1 రాయాలా? ఎందుకంటే L1 ఇంటూ V L1 ఇంటూ రో కరెక్ట్. దట్ ద ప్రింటింగ్ మిస్టేక్. VT0 ఇక్కడ కూడా దిస్ ఈస్ L1. సో దేర్ ఫోర్ V ఇంటూ T1 we go into T0 and see the same as అంటే మైనస్ ఇట్ వస్తే ప్లస్ అవుతుంది. కరెక్టే. VT1 into under root of T1 we are simplifying here. So VT1 under row under root of VT0 into VT1. So therefore multiply L0 to multiply చేసిన పై దాన్ని VT0 into VT0 into T1 by under 2 under root of V into T0 into T1. So that is the multiplication 1. V into T1 under row under root of VT0 into VT1, but the multiplication. So efficiency is given by VT0 by VT1 is equal VT1, that is VT0 by T1 and E got treat చేస్తే from 2.1.4 we have the table we have take here. L0 VT0 by E minus rho under root of VT0 into VT0 by, there is a simplification we have done here. VT0 into VT0 by E minus 2 rho మీద రాసిందే రాశాను. L0 1 by E, దీని simplification అంతా. This is a simplification, that is there is a VT0 by E 1 by E. So that is rho E by E. This is a simplification of 1 by 1 plus 1 by E and 2 rho by E we are writing here. సో T0 is equal to under root of LCM చేస్తున్నాం మనం ఇక్కడ. LCM చేస్తే రూట్ E మైనస్ రో ఆఫ్ PE బై ఇక్కడ కూడా E ప్లస్ అంటే E ప్లస్ 1 E ఆఫ్ E ప్లస్ 1 మైనస్ 2 రో 2 రో E రూట్ E మల్టిప్లై చేస్తున్నాం ఇక్కడ. సో L0 is equal to 1 మైనస్ ఏం కామన్ తీస్తున్నాం ఇందులో నుంచి ఈ స్టెప్ నుంచి ఏం కామన్ తీస్తున్నాం? రూట్ ఈ కామన్ తీస్తున్నాం. రూట్ ఈ కామన్ తీస్తే 1 minus root e. Root e and e root e into root e కాబట్టి కామన్ తీస్తే e plus 1 by so therefore కండిషన్ మనకు తెలుసు L1 plus L0 plus L1 is equal to 1. L is equal to 1 minus L0 we are taking here. So therefore L1 is equal to N1 minus L0 1 minus 1 minus root I. So therefore L1 is equal to E minus root E by E plus 1 root E. So therefore with these values T0 T1 obtained this unbiased linear combination of T0 T1, the condition is satisfied here. So then another, this is the continuation of VT. This is asked main examination also. Who is Kishore? Tables ఎలా values వస్తాయి Kishore asking. In the next class I will tell you. Kishore, don't worry, I will tell you. Kishore, respond please. Who is Kishore? Respond. Okay. Don't have mic. Okay, no problem. Next week I will tell you. Tomorrow I will tell you, not tomorrow. Tomorrow I will tell you. Then don't next week. V of t is equal to 1 minus rho of t. V of t values ఇక్కడ రాస్తున్నా. 1 minus rho of t, e plus 1 minus 2 root of e whole square v t naught. E minus p root e. E minus vt1. అంటే ఇంతకుముందు ఫార్ములా ప్రకారంగా రాసాం. ఇగో ఇక్కడ కాదు, ఇగో ఇక్కడ ఇగో L square V naught 2 into L1 P V T naught rho into T1. So this one may be simplification here. 1 minus rho into E plus 1 minus rho into E minus rho into root E plus 1 minus 2 into root E, covariance of T0 T1. So variance of T we are taking here, variance of T 1 minus rho T of rho of root E by E plus 1 minus root 2 root of E whole square V T naught. E minus root E V plus 1 2 root E V naught T V naught. ఇక్కడ ఇది V naught T by E. ఇది VT1, ఇది VT by E. ఇక్కడ కూడా అంతే 2 into sigma 1 minus root E P E plus 1 minus 2 root E P. Again 1 minus కామన్ తీస్తున్నాడు, కొన్ని క్యాన్సిల్ అయిపోతాయి. So this is also covariance V2 naught by root E. So this is the after the VT naught by E plus 1 2 rho sigma square simplification చేస్తే this is called as this is one theorem. It is a derived point of the variance of the component of naught. It's almost all the theorem you have to do in the main examination. Any doubts? Any doubts?
No, sir.
Okay. Tomorrow onwards, you check your progress here. Sufficient estimator. Fisher name అని అందరూ విన్నారా? మళ్ళీ ఒకసారి బేసిక్స్ చెప్పాలా? ఫిషర్ నేమ్ అని విన్నారా అందరూ? చదవండి, డౌట్స్ ఏమైనా ఉంటే రేపు క్లియర్ చేస్తా. ఓకేనా? ఇదంతా ఫిషర్ నేమ్ అని. ఫిషర్ నేమ్ అని చదవండి, డెన్సిటీ ఆఫ్ ఫ్యామిలీ చదవండి. క్లియర్?
Sir, yes, sir.
కనిపించినాయి కదా? కనిపించినాయి కదా?
Sir, 133 అనా?
Any doubts? Ask me. iPhone, Kishore, Monica, Rupa, Surya. Any doubts? Ask me fast. Any doubts? Komal?
లేదు సార్.
రైట్, రేపు థర్డ్ అండ్ ఫోర్త్ డిస్కస్ చేద్దాం. ఓకేనా? ఒకసారి చూసుకొని రండి. ఇది మాక్సిమం లైక్లీహుడ్ రేపు చూద్దాము. ఇందులో డో స్క్వేర్ ఎల్ బై డో ఎస్ స్క్వేర్. ఫోర్త్ యూనిట్ కూడా ఏముంది అనేది ఒకసారి చూద్దాం. ఉండండి, ఫోర్త్ యూనిట్ కూడా ఏముందో. జస్ట్ స్టే ఆన్ ద లైన్ ప్లీజ్, ఆల్ ఆఫ్ యూ.
Concept of different hypothesis.
యూనిట్ మోస్ట్ ఇంపార్టెంట్ యూనిట్ నల్ హైపోథిసిస్ ఆల్టర్నేట్. ఆల్రెడీ మీరు డిజైన్ ఆఫ్ ఎక్స్పెరిమెంట్ చదివినారు కదా ఇది.
Yes, sir.
నల్ హైపోథిసిస్, ఆల్టర్నేటివ్ హైపోథిసిస్, టైప్ 1 ఎర్రర్, టైప్ 2 ఎర్రర్ చదివినాం కదా. టైప్ 1 ఎర్రర్,
సార్ చదివాం సార్.
టైప్ 1 ఎర్రర్, టైప్ 2 ఎర్రర్ చదివినాం కదా. సో టుమారో థర్డ్ అండ్ ఫోర్త్ యూనిట్ వీ కెన్ ఎక్స్ప్లెయిన్. ఓకే, ఓకేనా?
Okay, sir.
రైట్. ఒకసారి చూసుకోండి, చూసుకొని వస్తే వీ హ్యావ్ టు డిస్కస్ టుమారోస్ క్లాస్. షల్ ఐ లీవ్?
సార్ మ్యాథ్స్ ఏమైనా తీసుకుంటున్నారా?
లేదమ్మా,
సార్
లేదు 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 లేదు
తీసుకోవట్లేదా?
లేదు. So you have to practice tomorrow 3 and 4. We can discuss tomorrow's class again. Thank you.